Alright, hey guys, once again welcome to our channel. Hopefully you guys are doing great. In today's video we'll be dealing not with a new concept actually, but it's continuation of one of our concepts that we were discussing in our previous videos. Um, that was about electronic configurations. So in today's video, as you can see just by the video's thumbnail, the concept that we're going to deal with in today's lecture will be determining electronic configurations. So here we will learn how the periodic table is split up into different blocks, and we'll also learn about how we can determine the electronic configuration methods, two methods basically, the full electron configuration and shorthand version that we'll be discussing in today's video, and we'll be discussing some examples as well, so you are clear, so you don't have any queries concerned with the topic. Okay, so without wasting our precious time, let's get into the topic. All right. So first point, writing out the electronic configuration tells us how the electrons in an atom or ion are arranged in their shells, subshells, and orbitals. So as you're writing the electronic configuration, this will let you know how the electrons occupy themselves in different orbitals, in different shells, subshells, orbitals, and there are various methods. There are not various actually, but there are two methods that will help us do this, that it will help us determine or write out the electronic configuration. So let's see those two methods first. So the two methods that we have is the full electronic configuration and the shorthand version. Now what does these two actually mean? So let's look into firstly the full electronic configuration. So basically the full electronic configuration will describe the arrangement of all the electrons from the 1s subshell up. So for example, let me take an example of a potassium atom. Let's say it has 20 electrons. Okay, so to write the full electron configuration of that potassium atom, what I will do, I'll start from the first shell, that will be 1s2. Then I'll go further, 2s2, 2p6, 3s2, 3p6, and 4s2. This will be the complete electronic configuration of the potassium atom. Okay, now if some questions ask you about the shorthand version, okay, shorthand version, if they ask you what you will do, that it includes using the symbol of the nearest preceding noble gas to account for however many electrons are in that noble gas. So examination question may state what is the shorthand version maybe of potassium atom, let's say. So firstly what you need to do, you need to check to which noble gas is the potassium atom is the closest. So then you will see which one, maybe it's probably it's argon in the periodic table. So we'll be using the symbol of argon to account for how many electrons are in that noble gas. All right, let's move on. Now, ions. Already we have learned many concepts from IGCSE. We have been learning not from IGCSE, basically from, let's say, from grade 8 maybe. Okay, we have been learning about ions. Now we'll recall what are ions. So ions basically are formed when atoms lose or gain electrons. So already we discussed in our previous videos, make sure you check out them. So there are two types of ions, negative and positive ions, and their formation is a bit different from each other. Negative ions, how they are formed by adding electrons to the outer subshell. This means I am just adding negative charges. This means I'm increasing the negative charges, and the atoms are becoming negative ions. For example, if I take an atom, a neutral atom, and I am adding more and more electrons, now if you see, the number of electrons will be more compared to the number of protons. So in this case, a negative ion is formed. Talking about positive ions, now positive ions are formed by removing electrons from the outer subshell. Okay, so they're formed by removing electrons from the outer subshell. Again, let's take an example. Let's say we have an atom and maybe it has 19 protons. Let's say 1 was potassium. Yeah, it was potassium. So I have an atom of potassium and I need to form a positive ion. So what I will do in this case, I will be removing electrons from the positive ion, making sure that the negative charge is less than the positive charge. So if negative charge is less than the positive charge, then overall it will have a positive charge and the ion will be also positive. Talking about transition metals, the one that are found in the midway of the periodic table. So these transition metals fill the 4s subshell before the 3d subshell. However, we learned that metals, all not metals, all the elements basically, they actually are filling in order of increasing energy. Now it says the transition metals fill the 4s subshell before the 3d subshell. Why is it so? And we discussed this reason in our previous videos. Because the 4s subshell is lower in energy. This is the reason. So as we know that the atoms, as we know that the atoms are filling electrons in order of increasing energy. Okay, in order of increasing energy means from lowest energy to the highest energy. Now lowest energy will be from 4s and the 3d subshell is higher in energy compared to 4s. So that's why we are saying that they fill the 4s subshell before the 3d subshell. Okay, now if they lose electrons, the decrement or the loss of electrons will be from the 4s first and not from the 3d subshell. Again, the same reason applies here, that the 4s subshell is lower in energy compared to the 3d subshell. Alright, moving on. Splitting of the periodic table. Now here comes our first main point, that was how the periodic table splits itself into different blocks. So let's say, now periodic table, if you see the periodic table real image, you will not see that these are notified by these blocks elements. So we ourselves have to split this periodic table into different block elements. Alright, so the periodic table is spread up into 4 main blocks. So there are 4 main blocks depending on the electronic configuration. Okay, now S block elements, P block elements, D block elements and F block elements. Okay, so now how we can distinguish between them, how we can differentiate between these block elements. It's very easy. Now if we talk about S block elements have an identity that they have their valence electron or their outermost electron in an s orbital. Okay, so for example, if you take an example of hydrogen atom, okay, so let's say it's in group 1, right? So its electronic configuration is 1s2. You will see that S, okay, that S is the orbital in which the outer electron is present, in which the valence electron is present. Now talking about P block elements. P block elements are basically from group 13, group 13 to the noble gas. If you take any element of the group 13, let's take from the group 13 to group 18, no, the group 0 noble gases. So if you take, for example, let's say you're taking what you will take, maybe chlorine. Okay, you will see that the outermost electron will end up in a p orbital. Likewise, similarly for D block elements, and the same logic applies to F block elements. So D block elements have their valence electron in a d orbital, and F block elements have their valence electron in an f orbital. So it's all about concerned with the outer electrons, okay, and to which block it belongs. So S block is the first two groups. P block is from group 13 to group 0. D block elements is from you will see that it was the transition metals, okay, where the transition metals are present. The midway block is the D block. F block is the lanthanides. Okay, so this is all about splitting of the periodic table. Moving on. Okay, one second. Moving on here. Now this is the real image. This image will help you understand all this theory. Like orally explaining was a bit difficult, so I took this image to make you understand better. Okay, now we'll see here that this is the S block. Okay, this is the S block. Transition metals is the D block. P block is from group 13 to group 17, group 0. F block elements is the lanthanides and actinides. Okay, so probably they are not asking about F block elements, because F block elements, if you talk about F block elements, they might ask you basic things. They might ask you how you can differentiate between F, S, P and D block elements. Okay, But if they're telling to find the electronic configuration, they won't give you any element that has too many electrons. For example, iodine, it has 53 electrons probably, so they won't give you that much big element in your examination questions. However, you need to know how we can determine the electronic configurations, even though they don't give you these type of questions, but you should be aware of them. Okay, so the elements can be divided into 4 main blocks depend according to their outer shell electronic configuration. Okay, so this you need to understand. Moving on to the next concept, that is exceptions. Now, it's not a concept actually, it's exceptions basically are those that not some elements, there are 2 of the elements, they do not follow the sum of the main rule of electronic configuration, the main rule of filling or electrons occupying the shells or orbitals. So let's see what are those 2 elements. Now, chromium and copper, these are the 2 main elements that have the following electronic configurations that are different to what you may expect. So maybe your teacher asks you, or your board exam, your curriculum, chemistry curriculum asks you to determine the electronic configuration, to write out the electronic configuration of these 2 atoms, chromium and copper. Okay, you know the answer. Now you are just using the method of the notes given to you, your teacher's methods, my method maybe if you're watching my video, and you will determine the electronic configuration. Even if you determine your electronic configuration in a proper way, you will get your answer wrong. Why is this? Because these are exceptions. That's why. These are exceptions, that's the reason. Okay, so for example, we discussed from chromium. Now chromium, it's a shorthand version, that is Ar, that argon is the nearest pressing noble gas. Okay, so it has argon, 18 electrons, that of argon, and then it has 3d54s1, and it's not Ar3d4s2. Copper is Ar3d10 4s1 and not Ar394s2. Now there's a reason behind it. This is because the Ar3d54s1 and Ar3d10 4s1 configurations are energetically stable. So this is the main reason that why chromium and copper have these electronic configurations, which are different to what you may determine. Alright, now we have some worked examples of electronic configuration. Let's see. Now, the question asks here to determine the full and shorthand electronic configuration of the following elements. So firstly we have potassium, secondly we have calcium, third is the gallium, and fourth is the calcium ion, that is 2+ positive ion. Let's see for the first one, potassium. Now, as we know from the periodic table that potassium has 19 electrons, so the full electronic configuration is what? Let's see. This is the full electronic configuration, that is 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. Again, we can just apply the rule of the splitting of the periodic table, how the periodic table helps us know. Okay, so potassium, it's in group 2, and this is the s block element, and you can see the outermost electron ends up in an s block. So that's what I'm trying to explain you. And there is a difference also here, that 4s orbital is lower in energy than the 3d subshell and is therefore filled first. In this case, this is just a point for explaining you. Okay, in this case of potassium, we don't have any 3d subshell, so that's why this is not an important point in this question. But the questions involving 3d subshell, there will be some question that involve 3d subshell. So in those cases, you need to understand that 4s orbital will be filled first, then the 3d subshell. The nearest preceding noble gas to potassium is argon. Alright, so now comes for the shorthand version. The nearest preceding noble gas to potassium is argon, okay, which accounts for 18 electrons. So potassium, argon has 18 electrons. So potassium, when you're writing the shorthand version of that, it will be Ar in bracket, that's argon, electrons, that are 18 electrons, plus you need one more electron, that will be 4s1. Okay, 1s2, 2s2, 2p6, 3s2, 3p6 is the electronic configuration of argon. For potassium, the shorthand version will be bracket, square brackets, Ar, okay, and we'll be having 4s1. Let's see, this will be the electronic configuration of the potassium atom, that is shorthand version, okay. Now, talking about calcium. Now, calcium has 20 electrons, okay, 20 electrons according to the periodic table we know. So the full electronic configuration will be what? So it will be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. Now things in scenarios where we have maybe an element that has too many electrons, okay, maybe it has 60 electrons, maybe let's say it will be having 56 electrons. So in those cases it is very difficult, okay, not difficult, you can do it, I know, but it's very lengthy, it will take a lot of time, it will consume a lot of time, and maybe there are many questions in your examination and you may lose some marks according to that, okay. So in those cases we use this shorthand version. Now the 4s orbital is lower in energy than the 3d subshell and therefore filled first. In this case also we don't have any 3d subshell, so we are going to ignore this point. This point is just again repeated to make you understand that whenever we are dealing with 3d and 4s subshells, you need to understand that 4s orbital is already filled, is lower in energy, so it's therefore filled first. The shorthand version of calcium atom is Ar4s2. Since argon is the nearest preceding noble gas to account for which accounts for 18 electrons, okay. And calcium atom, if you see again, if you compare it to our previous example, that potassium was 19 electrons, calcium is 20 electrons. We know that argon is 18 electrons, okay. So that 1s2, 2s2, 2p6, 3s2, 3p6 is the electronic configuration of calcium argon atom. So we can write just square brackets Ar plus 4s2. Something like this will be Ar, let me just highlight it so you can just see here, okay, like this, Ar 3d 4s2, okay. So this would be the electronic configuration for calcium atom. Now talking about gallium. Now gallium has 31 electrons, so the full electronic configuration is, this is not a full electronic configuration actually, but you know, since gallium is a large element, okay, it has many electrons, 31 electrons, and to draw the 31 electrons it will consume a lot of time. So that's why we are writing the example of gallium as like this in the shorthand version, okay. Now as we know that square brackets Ar, that's the electronic configuration of argon, that's 18 electrons. If you write, okay, that will be 1s2, 2s2, 2p6, 3s2, 3p6, that will be electronic configuration of argon. So we have replaced those electronic configuration for the argon symbol in square brackets. Now 18. Now we'll go to the next subshell after 3p6. So 3s2, 3p6, 3a10, 4s2, 4p1. Now here you need to understand that we are involving here 4s and 3d subshells. This means that 4s will be have to fill first before the 3d subshell, okay. So don't do like this that you fill 3d subshell before the 4s. Firstly fill 4s, then you go to the 3d subshell, okay. Moving on. Now question number 4. What this means is that if you ionize calcium, okay, basically we saw the example of calcium in the question number 2. In question number 4 we have a calcium ion. Now already we know that calcium has 20 electrons and its electronic configuration we know already, the shorthand version as well as the full hand version, the full hand electronic configuration. Now we are ionizing calcium. We need to understand what is the calcium 2 plus ion. So we have taken, this means we have taken a calcium atom and we have removed its two of its outer electrons, okay. So and that's how we have formed calcium 2 plus ion. Now if you compare the calcium 2 plus ion to argon, you will see both of them will have the 18 electrons. Both of them have same electrons, same number of electrons. So that's why the electronic configuration, the full hand version, will be 1s2, 2s2, 2p6, 3s2, 3p6, similar to that of argon. And we know argon is also 1s2, 2s2, 2p6, 3s2, 3p6. So both have same number of electrons. and that's how. We can also write the shorthand version, just square brackets AR and nothing except that. Okay, and this is how that we are done with determining of electronic configurations. I think there are some concepts left actually to discuss in electronic configurations. Soon we will be starting with ionization energies. It's a very interesting topic. No, we are done actually. Yeah. So we are done with the electronic configurations. There's nothing more to go. We have discussed everything: electronic structure, electronic subshells and orbitals, electronic configuration, determining electronic configurations. Okay, we have done everything. And in the next concept, we'll be discussing ionization energy. So just make sure you're tuned for that video. And yeah, nothing else. That's it for today's video. And make sure you're subscribed to the channel, hit the like button, comment down below, so as per your suggestions we can improve our content, we can improvise our content, and mention any concepts that are going to face difficulty in. Probably I know if I receive any comments about the topics that the viewers are confused in, that probably will be organic chemistry or inorganic, because that's the most what you will say that you will be facing most difficulty in those topics. Yeah, that was my experience when I was in grade 11. All right, nothing else for today. That's it. Cheers.